Hello students, welcome back to your online video classes. In the previous class, we have started the topic electric current, in which we discussed first of all the basic definition of electric current, then resistances and potential differences. Then in the next class, we discussed the combination of resistances. First of all, series combination, and second one was parallel combination. After that, we solved some numericals based on these combinations. Then we started the discussion on thermal effect of current, that is the law of Joule heating, in which the electric energy is converted into the thermal energy in the conductors. So, the temperature of these conductors rises. After that, the production of electric energy, we studied the electric power, that is the rate of production of electric energy. The unit of power is watt. So, several other units involved in the electric power is kilowatt, megawatt and horsepower. 1 horsepower is equal to 746 watt. Then we also solved an example 7 based on the Joule's heating effect. Then the magnetic effect of current, that is formation of magnetic field lines due to the current. Then we studied how you can determine the direction of magnetic field. Right-handed corkscrew law, that is the movement of screw, that is the rotation will denote the magnetic fields, and the going upwards and downwards knob is known as denotes the direction of current. After that, we studied the second law, that is the right hand law, in which the fingers curling around the palm denotes the direction of magnetic field, and the thumb pointing upwards or downwards denotes the direction of current. The magnetic fields, as you know, comes outwards from the north pole and then comes inwards towards the south pole. Now, in the previous class we have discussed the formation of magnetic field lines due to electric current. Now, in today's discussion we will produce electric current due to the magnetic effect. So, a magnet will be placed near a coil in which a galvanometer is connected and a closed circuit is made. After that, a magnet is moved towards the coil. After that, the magnetic field lines, due to the relative motion of coil and magnet, the magnetic flux changes in the coil, and due to these magnetic field lines changing in the coil induces the current, and this induction of current is known as electromagnetic induction. So, basically electromagnetic induction is production or induction of electric current due to the relative motion of magnet and coil and changing the magnetic field lines in the cross section of coil. So, these kinds of terms, that is the number of lines passing through the cross section, is represented by a common term, that is magnetic fields. Magnetic flux. Magnetic flux is the number of field lines of magnet passing through a coil perpendicularly. So, the formula of magnetic flux is NBA cos theta. Theta is the angle between B and A. A is the cross section of the coil and is perpendicular to the plane of coil, and magnetic field will have a specific direction in a particular question. If the angle between B and A is 90 degree, then the value of cos 90 is 0, so magnetic flux will be 0, and then change in magnetic field will be 0 as well, so there will be no induction or production of current. But if the area of cross section and field lines are making an acute angle or the 0 degree angle, then there will be a specific value of flux, and then that change in flux will induce the current. If flux is not changing, that is if the relative motion between the magnet and coil is 0, suppose they are moving in the same direction and with the same speed, then their relative speed will be 0 with respect to each other, and at that condition flux will be 0 and the rate of change of flux will be 0, and if flux is not changing, that is the magnetic field lines passing through a particular cross section is not changing, then there will be no current in the circuit. The unit of flux is Weber according to the name of a scientist. This law of induction of current by the change in flux is given by the scientist Faraday. So, after the magnetic flux and common terms of EMI, that is the electromagnetic induction, we will study its application. So, the first application based on the EMI is AC generator. The current AC which is used for the working of our appliances like fan, geysers, heaters. So, these all appliances work on the principle of AC, alternating current which changes its direction and have a particular frequency. In India, this frequency is about 50 Hz. So, in an AC generator, mechanical energy, that is the rotation of a coil, it is a mechanical energy which is converted in the form of electrical energy. When there is any fault in the electricity, then this generator is used by converting the mechanical energy into electrical energy. So, first of all we will discuss the construction of AC generator and then we will discuss the working of generator. So, first of all in construction, there are mainly 4 components working in it. First of all, field magnet. These are the very large, powerful, horseshoe shaped magnets which produces the radial magnetic field perpendicular to the coil. So, if the magnetic field is perpendicular to the coil and then this is the radial magnetic field. Second one is armature or coil that will rotate for inducing the current. This coil is made up of copper so that maximum amount of current can be produced. Third one is slip rings. These slip rings are 2 in number in the AC generator. These slip rings are connected to the armature or coil for the proper conduction and the proper movement of armature. These 2 split rings are insulated from each other, they have no connection with each other and working independently. So, the fourth one is brushes. These brushes are made up of the insulating materials and are connected to the slip rings and the outer circuit of electric appliances, in which we have to use that electrical energy produced. So, now in the working of AC generator, magnetic field lines are produced by the magnet and by using the mechanical energy, armature or coil will rotate and due to that rotation, the angle between the field and the area of cross section, that angle will change, and due to the change in angle, the flux, magnetic flux will also change, and as you know by the law of Faraday, the change in magnetic flux will leads to the production of current. So, in the AC generator, these slip rings works independently. So, in a particular direction after a particular time interval, or you can say by a particular frequency, the direction of current is changed in the AC generator, because AC is actually alternating current, that is the current is changing its direction alternatively. First of all, when flux increases, then the current will have a particular direction, and when flux decreases, then current will change its direction in reverse. So, due to that change, the current in the outer circuit will also change its direction. Suppose first of all the current is moving from brush 1 to brush 2. So, if in the first case current is moving from B1 to B2, that is from brush 1 to brush 2, that means the brush 1 will have the positive terminal of battery and B2 will have the negative terminal of battery. Then in the second case it will move from B2 to B1, that means current changes its direction and polarity of the brushes changes as well. Opposite to the AC generator, DC generator works, in which the construction is almost similar, there is change only in the slip rings and brushes. So, in the DC generator is a direct current in which a maximum and constant value of current flows. So, first of all, field magnet, in which a powerful horseshoe magnets are used. The shape of horseshoe magnet like is basically for generating a radial magnetic field. Second one is armature or coil, that copper coil which by rotating changes the magnetic field flux, and due to the change in magnetic flux current is induced. Third one is single slip ring commutator. So, in the previous one, that means in the AC generator there are 2 separate slip rings, but in the DC generator there is a single slip rings which is divided into 2 parts and denoted by commutator 1 and 2. It means they are not working independently and are not insulated from each other and are working with a proper coordination. And the fourth one is brushes, that is B1 and B2 as well. Now, in DC generator, when magnetic field is produced and armature or coil is rotated by the mechanical energy, then angle will change and flux will also change. But at this time, single slip rings will not change their polarity. So, if first of all B1 is connected to C1 and B2 is connected to the C2, then current will flow from B1 to B2. That means the polarity of B1 is positive and of B2 will be negative. Now, these brushes will change their position. B2 will connect to the C1 and B1 will connect to the C2. If the polarity of C1 and C2 is changed, now in the previous one C1 was positive, so B1 was positive, and C2 was negative, so that B2 was also negative. But now the polarity of C1 and C2 is changed according to the change in flux. So now C1 is negative, but B1 was positive and will remain positive. But now it will connect to the positive one commutator, that is C2. So connection will change. B1 will connect to the C2, that is positive, and B2 will connect to the C1, which is now negative. So B1 will always remain a positive terminal and B2 will always remain a negative terminal. So direction of current will be fixed in the direct current, and that is B1 to B2. But in the AC generator, the current direction of current is changed. First of all it was B1 and B2, and then it is B2 to B1. But in the DC generator, the direction of current do not change and it will always from B1 to B2, from the positive terminal of battery to the negative terminal of battery. Now we will solve some numericals related to the electric current. So the first question on page number 145 is, a 2 ampere current flows in a conductor connected with a 5 volt battery. You have to find the resistance of the conductor. So current is given 2 ampere and the potential difference is given, that is the cause of current flowing, that is 5 volt. So resistance will be V by I and 5 by 2 is 2.5 ohm. So the answer will be the B option, 2.5 ohm. Now the next numerical question is question number 7. The question is, 2 coulomb charge passes through an electric circuit in 0.5 second. You have to find the value of current in ampere. So charge is given, that is 2 coulombs, time is given 0.5 second, and dividing Q by T, that is electric current, will be equal to the 4 ampere. Next question, that is numerical 1, is question number 30. Find the highest and lowest resistance from combination of resistances of 1 ohm, 2 ohm and 3 ohm. You have to calculate the highest and lowest resistance. Highest resistance will be the resistance of series combination. So letting it to be the series combination, you will simply add the various resistances and the answer will be 6 ohm. So the highest resistance is 6 ohm and the lowest one is the result coming out from the parallel combination is the lowest resistance. So by parallel combination, by calculating, you will have the value of lowest resistance, that is 6 by 11 ohm. Next question, that is question number 31. What will be the resistance of a conductor wire when the potential difference across its terminals is 2.5 volt when 10 milliampere current flows through it? So in this question, potential difference is given 2.5 volt and current is 10 milliampere. That is the smaller one unit of current. So you have studied that 1 milliampere is 10 to the power minus 3 ampere. So by converting the milliampere into ampere, you will solve for resistance. The formula is V by I. So by calculating it, you will get the answer, that is 250 ohm. Now the next question, that is question number 32. Find the equivalent resistance between A and B in the following circuit. So in the A1, a triangle is given in which in all the sides of the triangles various resistances are connected. Between the AB, you have to calculate the R equivalent. So first of all, these two are in the series combination. So by simply adding, their equivalent will be the 4 ohm. And now between A and B, there is one 4 ohm resistance and one 2 ohm. These are in parallel combination and by solving you will get the answer, that is 4 by 3 ohm. In the B part, a circle is given in which 4 resistances are connected. First of all, between A and B point, the upper two ones, 2 ohm, are connected in the series and the lower one are also connected in series. So their value will be 4 ohm. Then these 4 ohms are connected in the parallel, so the R equivalent will be 2 ohm. The C part is a square form in which every side has a value of 2 ohm resistance. So between A and B, these two resistances are connected in series and these two are connected in series. So the value of these are 4 and the upper ones are also 4. So by the R parallel, calculating the R equivalent, the parallel combination of 4 ohm and 4 ohm will be 2 ohm. So this was the C part, and in the D part, 3 resistances of the value 3 ohm are connected in parallel, and then these are connected in series with the same combination and with the 1 ohm resistance. So the value of R parallel will be 1 ohm, and in the second parallel circuit this will be also 1 ohm. Then these 3 are connected in series. So the R equivalent will be 3 ohm. The last question, that is question number 33, an electric rod of 1500 watt. So power is given, that is 1500 watt is used in 3 hours, is used for 3 hours daily to heat water. If the rate of consuming 1 electrical unit energy is rupees 5, then you have to calculate how much will be the value of consumed electric energy in 30 days. So as I have told you that the practical electrical energy used are in the units of kilowatt and hour. So you have to calculate the time in the terms of hour and the power in the terms of kilowatt. So 1500 watt is converted to kilowatt by dividing by 1000. So answer will be 1.5 kilowatt, and time will be 3 hours daily. Then for 30 days it will be 90 hours. So by dividing the power to time, you will get the total electrical energy. And as you know, for 1 kilowatt hour energy, rupees 5 are used. So for 1.5 multiply to the 90, that means the total amount of kilowatt hour energy, then you have to multiply that amount with the unit amount. So by multiplying these, you will get the answer, that is rupees 675. So now today we have completed our discussion on the topic electric current, in which we studied about the electromagnetic induction, that is generation of electric current by the changing field lines. Then we studied the alternating current and the direct current. That means in alternating current direction is changing, and in direct current direction of current will be constant. In the generators, the mechanical energy is converted into electrical energy. Thank you.